Welcome to another important lesson that we are going to go through today. My name is Siamasaka Kilian Dens. I'm going to take you through dimension analysis. You know, dimension analysis is very important because in physics, we always look at the consistency of the dimensions as well as whether appropriate units are used for a particular quantity. You know, if you don't express a quantity in appropriate units, it becomes vague. It means that it cannot explain anything for that particular quantity. And therefore, there we go. Actually, dimension analysis helps us to check the mathematical relations for the consistency of the dimensions for a particular quantity. In other words, what it means that if we have an equation, there could be certain parts which actually, or the equation which can be expressed as dimensions. And this is what we're going to discuss today. And so today we'll look at questions to help us understand dimension analysis. And so here is the first question. For the equation below, use dimension analysis to find dimensions of pressure, where F is the force and A is the area. We are aware that pressure is expressed as follows. Pressure is equal to force over area. And force can be expressed as mass times acceleration. And therefore, pressure again can be expressed as mass times acceleration over area. Now, if we want to get the dimensions here, we can get the dimension of mass, which is m, and the dimension of acceleration, which is mass, which is meters per square seconds. And therefore, the meters can be expressed as length, which is L, and then the time can be expressed as t squared, divided by area, and the area can be expressed as length times length, which is length squared. And therefore, you may get the reciprocal of this, and you find that after cancelling L here and another L here, you find that the dimensions of pressure are mass, which is m, divided by t squared multiplied by length. So this is how we do analyze the dimensions of a quantity. For instance, in particular today we've looked at pressure. Here's another question. For the equation below, where E is kinetic energy, C is a constant, and m is mass, and v is velocity, use dimension analysis to calculate the values of alpha and beta. And therefore, you know, acceleration is, you know that kinetic energy can be expressed as half times mass times velocity squared, which is equal to c, a constant, multiplied by m to the power alpha multiplied by velocity to the power beta. And therefore, half is actually a constant, and therefore it has no dimensions. And then we have mass, which is multiplied by length to the power 2 over time to the power 2, as this is velocity, which is equal to the constant, which has also no dimensions. And we have m to the power for mass to the power alpha, and this is velocity, which is the length for meters to the power beta over the time to the power beta. And therefore, when you have such an equation, you can actually look at the like terms here and equate them as such. And so here we have m to the power 1, which is equal to m to the power alpha. And therefore, since the bases are the same here, you know that alpha is equal to 1. And therefore, because the powers can be expressed as an equation, since the bases are the same. And similarly, for time, time here, since it's a denominator, when you put it as a numerator, it means that it will be t to the power negative 2. Similarly, this one it will be t to the power negative beta. Therefore, you can equate them. And you notice that the bases are the same, and therefore you can say negative 2 is equal to negative beta. So negative beta is equal to negative 2. Then the negatives can cancel out. So you have beta is equal to 2. So the value of that one. We can as well look at the length. Length, it is the L to the power 2, which should be equal to L to the power beta. And therefore, you can equate them as such. And since the bases are the same, so it means that the powers can be expressed as actually beta is equal to 2. And so this is how we can use the dimensional analysis when we are equating equations. I hope you can subscribe to this equation and this lesson for me, and then you continue getting more lessons of this kind. I thank you.